All right, so direct and inverse variation. My guess is, yes, sir.
Are you recording?
I am. I just hit record. Thank you, though. Direct and inverse variation is probably something that you saw in Algebra 1. I feel like Mr. Samuelson does direct variation for sure. I'm not sure if he does inverse variation in Algebra 1, but my guess is wherever you took algebra, you've seen a little bit of this at least. So direct variation is what we're going to start with, and then we'll talk inverse in just a minute. But direct variation is basically saying when your x values and your y values are moving in the same direction, okay? So basically, if your x value goes up or your first number that you're talking about goes up, I'm going to write the word. I don't want you thinking, we'll just write the word. Then the second quantity is going to go up as well, okay? If your first quantity goes down, then your second quantity is going to go down as well. So they directly relate to each other. It's direct variation. So just a couple examples to give you kind of a visual of what this would be. If you're going on a trip, sorry, there's a hair in my face and I can't get it out. The distance that you travel will be directly related to the time that you spend, right? So the more time you spend, the longer you travel, right? They're both going up. Or buying something. If you're going to buy something by weight, the more it weighs, the more it costs. So if it was 2 ounces, it was $4, but if it was 10 ounces, it's going to be more money, right? So the more it weighs, the more it's going to cost. Sorry, I keep going like this because I'm doing a coordinate plane, but that would be this way for you guys. Okay, so the formula that is used for direct variation, the equation that is used for direct variation looks like this. Y equals kx is a direct variation equation. When you do this, we're going to solve typically for that letter k, because k is a constant. K is a number that does not change. It is a constant. Okay, so in solving for k, we end up getting a proportion, right? If I took this equation right now, y equals kx, and I was going to solve for what k is, I would divide by x on both sides. So k is always equal to our y value divided by our x value. Okay, so whenever you are solving for k with direct variation, because inverse is going to be different, okay? When it's direct variation, you're going to set up proportions. Y over x equals y over x equals y over x. Okay, that's a proportion, right? Something over something equals something over something. So just remember, direct variation, set up proportions. That will be really helpful. Okay, so let me show you how we do this. And you've done this before. You just haven't addressed it as direct variation necessarily. But it says if 4 bottles of milk cost $2, how many bottles can I buy for $8? Okay, so it's your one quantity over your other, right? The comparison of the two equals the one quantity over the other again. Y over x equals y over x. So I'm going to call this $2 for 4 bottles equal to something over something. Where does this 8 go? On the top. It's dollars over dollars, right? You want the two that relate across from each other. So 2 over 4 equals 8 over x, and then you cross multiply it. 32 equals 2x, divide by 2. So x would be 16. So how many bottles can I buy? I can buy 16 bottles, right? The more the bottles, the more it costs. They're both moving up. So that's direct variation. Okay, so setup number 2 for me. It says a 10-minute phone call costs $1.20. How much does a 23-minute call cost? What do you do? Okay, so you can do $1.20 over 10 minutes equals how much does it cost would be x over 23 minutes. Again, this is dollars, this is dollars, this is minutes, This is minutes, right? So you want that relationship there. Dollars across from dollars, minutes across from minutes, cross multiply it, and we get 10x equals, what does that come out to? 27.6 divided by 10. So x is 2.76. We're talking dollars. So $2.76 for a 23-minute call. Jada. So it really doesn't matter. Like, I could have set this up. In fact, in my notes I did, but because you guys said it differently, I just flipped it. I set it up in my notes, 10 minutes over $1.20 is equal to, if I'm solving for the amount of money, that's my unknown, right? It has to be money across from money. And it has to be minutes across from minutes. Does that make sense? So you have to match up the corresponding parts. Okay? Okay, so that's direct variation. With direct variation, you set up, what's that P word? Proportions, right? Direct variation, set up proportions. Okay. Inverse variation is just the opposite. This one says if the first quantity goes up, then our second quantity is going to go down. Or if our first quantity goes down, then our second quantity is going to go up. So it's like this, right? One's going up, the other one's going down, or vice versa. They will go in opposite directions. Okay, so some examples of when these types of things will happen. Work is a beautiful thing, right? If you have, this is maybe a bad analogy because I know some people don't show up for group projects, but let's say everyone is equally yoked and willing to work. If you have 2 people doing a group project and it takes 6 hours, well, what if you had 4 people? It better not take 10 hours, right? It's the same amount of work. Now there's more people doing it, so the amount of time it takes should go down if everyone's pulling their weight. Don't you wish everyone would pull their weight in a group project? Wouldn't that be lovely? If you're one of those people that doesn't pull their weight, pull your weight. That's so annoying for the people that do pull their weight. Anyway, so that's job site and job time. Another one, the speed of a car on your way to school and the amount of time it takes you to get to school. Might not always work, right? If you go real fast, you get a ticket, and then it's going to take you twice as long to get to school. But the idea is, if you're driving 25 miles an hour, it's going to take you, however long, depending on how far you live. But if you drive 50 miles an hour, you should get there a lot quicker because you went faster, right? The one's going up, the time's going down. Speed is going up, time's going down. Okay, so inverse variation, that's this equation. That is y equals k divided by x. We say it varies inversely. Think division when you hear that. So for that, we solve for k again. So if it's y equals k over x, and I'm going to solve for k right now, how do I isolate k? Multiply by x. So k is equal to x times y. Right? So when you are doing inverse, you are setting up products. The 2 numbers times each other equal the other 2 numbers times each other. Okay, products, multiplication. Questions on that? Okay, so it'll look something like this. Your x1 value times your y1 value equals your x2 value times your y2 value is basically what you're going to be solving. So let's take a look at this first one and see what that does. Goodness, that is really far across my page. Okay, example 3. It says you hired 3 people to paint a house, and it will take 2 days to paint the whole thing. How long will it take for 2 people to paint the house if one of the painters calls in sick? Okay, so you have to stop and think about that. Is this direct or inverse? It's going to be inverse because that's what we're talking about. But in the homework, you're going to have to choose. Is this a direct situation or an inverse situation? So when there's 2 people, it's going to take, when there's 3 people, it takes 2 days. If we drop a person, so our people go down, what's it going to do to our hours or days that it takes? It's going to go up, right? It's going to take longer with less people. So that's how you know it's inverse variation. Then what you do is you set up products, right? With inverse variation, you're going to set up products. So we're going to go 3 people takes 2 days. so 3 times 2, equals what? Two times how long is our x, right? So 2 times x. And then you just solve that. 6 equals 2x. So if it's only 2 people, instead of taking 2 days, now it's going to take 3 days. Okay, that is inverse variation. Okay, example 4 is a little bit trickier, just because you have to stop and think about what you're actually plugging in here. It says 50 kids are going to go to camp, and they have enough milk for 10 days for those 50 kids. If 15 kids don't drink milk, how many days will the milk last? Okay. So think about that. Is that direct or inverse variation? Inverse. One's going up. More kids, less days of milk, right? If less kids drink the milk, you'll have more days of milk to be drank. So are we multiplying or setting up proportions? We're multiplying. We're going to multiply our numbers. So it's going to be 10 times 50. Now stop and think about this. Equals what? 35, right? If 15 kids don't drink milk, that means 35 do drink milk. So 35 times however many days, I'm calling it D, you can call it X if you want. So then you solve that. 500 equals 35D, divide by 35, and we get D equals 14.3 days. Questions on that? Okay, so this is just a quick, lay it out. Here's what we talked about. When it's direct variation, you're going to set it up like this to solve. When it's inverse variation, you're going to set it up like this to solve. And these are the general equations that you start with if you're going to try and solve for K. All right? Here's part B. Do you need a little break or keep going? That is going to drive me nuts today. What time is it? 8:43. We okay? Okay. So now they're going to give you a chart, a set of numbers, and you're going to have to say, is it direct variation, is it inverse variation, or is it neither one? Okay. And then if it is direct or inverse, then you can find K. Well, that's not true. You're going to find K, and that's going to help you determine direct or inverse. Okay, so look at your numbers here. My X values to get to the next number, are they going up or down? Up. They're going up. My X values are increasing. Okay, what are my Y values doing? Increasing. 1.5 to 6 to 18. So if they're both increasing, this is potentially what? Direct, okay? So just remember that. This is maybe direct variation, okay? If it's direct variation, then we need a constant. So now we have to check, do we have a constant? Do we have a K? That makes sense here. So remember, with direct variation, that was our Y equals KX. So to solve for K, we set up proportions. So we're going to find a ratio, right? Y over X should equal Y over X, which should equal Y over X. So we're going to set this up 1.5 divided by 0.5, right? That's our Y value divided by our X value. Plug that into a calculator, you get 3. Now do the next one. Y value over X value, 6 over 2, you get 3. And it might be tempting right here to be like, oh, yep, they're the same, I'm done. You can't stop. They all have to follow it. Now, when you can stop is if one of them is different, it's not direct variation or inverse variation. So as soon as you see a different number, you can be done. But you can't be done until you see a different number, okay? Or until you check them all. Okay, so then the last one, 18 over 6, right? Y over X is 3. Is that a direct variation? Yes, you have a constant. 3 never changed, right? So we would say That is a direct variation because they were both going up, and k equals 3. Okay? What would the equation look like then? If I said, write the equation of the direct variation. Y equals 3x, right? You would just take that 3 and drop it into our equation. Y equals 3x. So this is the equation for that direct variation. Good there? Okay, letter B. So first thing you have to check is what? What direction are your numbers going, right? We got to figure out, is it direct, inverse, or potentially neither? So my x values, are they going up or down? X values are going up as we go through them. Y values are going down. So our potential right now is that it would be inverse, okay? We got to figure that out. Is it an inverse variation? We don't know yet. So for inverse variation, remember that was the y equals k over x. So if we're solving for k, it's a product, x times y. What do? Multiply all those numbers, right? 0.2 times 12 is 2.4. 0.6 times 4 is 2.4. And then 1.2 times 2, 2.4. Okay? Is that a constant? Yeah, k is 2.4. So we would say this is inverse variation. Our k value is 2.4. So my equation would be y equals what? 2.4 over x. Does that make sense? Okay. Letter C here. What's our potential? Direct, right? The x values are going up and the y values are going up. So if it's anything, it's direct. For direct, do we multiply or divide? Divide. Y over x. So we're going 2 divided by 1, which is 2. We're going 4 over 2, which is 2. And we're doing 9 over 3, which is 3. Is it direct variation? Mm-mm. So you would just say this is neither, and then you don't write an equation and you don't find a k because there is no k. All right. Okay, so now they're going to give us some information. You're going to have to come up with the equation, and then they'll give you some numbers to plug into that equation, and you'll solve, okay? So this first one, it says, suppose x and y vary inversely, okay? Inversely is going to be your y equals k over x situation, okay? So we're going to say y equals k divided by x, okay? And then it says x equals 4 when y equals 12. So we need to write this equation, but you always have to put a number in for your constant. How can I find k in an inverse variation? Do I multiply the 4 and 12 or divide them? In an inverse situation? Oh, did I say inversely? I did say inversely. Sorry, you multiply them. What did I do? Oh, I multiplied them, just not in my brain. So we're going to say multiply by x. So k equals x times y means k is 4 times 12. So k is 48. All right, so your answer, the equation, is y equals, drop that 48 in right here, 48 over x. Okay. Then it says find y when x is 7. What do you do? 48 divided by that x value, 48 divided by 7, and that comes out to not a beautiful number, 6.857. Okay, so really pay attention to the wording. If it says varies inversely, right, y equals k over x. If it says directly, y equals k times x. Okay, okay, so this one then. Suppose x and y vary directly. So your equation, y equals k times x, is going to be our setup. What do you do with the x and y values to find k? Divide, right? Divide by x, divide by x. So k equals y over x. So what is your k value right now? 3/10, right? Okay, so the equation is just drop that 3/10 into your original, y equals 3/10 times x. Then it says find y when x is 50. So you're just going to take that, y equals 3/10 times that x value times 50, and then simplify that. So 150 divided by 10, y is, or you can plug in 3/10 times 50 in your calculator, that's fine too. Y comes out to 15. Questions on that? Jada?
So I'm still kind of like getting something mixed up with like different procedures.
It's tricky, right? Because your equation for direct is like this. Multiplication, right? Y equals k times x is the equation that you're going to write. But to find k, you divide. So this is multiplication, but to find k, you do division, right? Whereas inversely, it's division for the equation, but you're going to multiply to find k. So it's kind of up to you how you want to think about that. Maybe you just always think of the equation like this, and then you solve for k every time, and then you don't have to worry about remembering products or proportions. But there are both things happening in both of them. So it's just a matter of keeping it straight, however works best for you. Okay, now we get a little bit fancy with it. Combined variations is going to throw all kinds of new words, not new words, all kinds of those words at you. Jointly is going to be the new word that you see. But basically, you're just going to have to take words and turn them into equations and then do some of this solving and setting up type stuff. So combined variations. This first one says z varies jointly with x and y. Okay, when you see jointly, you need to think direct variation. Okay, jointly, like working together directly. So this would be z varies, okay, is always going to be your equal. It's pretty much going to be your equal and your constant. So z equals k, and then jointly with x and y, you're going to multiply x and y. So if it says z varies jointly with x and y, you get z equals k times x times y, okay? Don't ever leave k out of these. It will never address the k. There's always a constant, all right? So the constant, it's always going to be equals k, and then whatever the wording says. Equals k, fill in the gaps. So this second one, z varies jointly with x and y, okay? That's exactly what we had before. Z varies, and then jointly with x and y, so that means multiply x and y, but inversely with w. What does that mean? Inverse variation, you divide, right? So it's going to be k times x times y, jointly with x and y, divided by, w. Does that make sense? All right, last one of these, and then we'll try some with numbers. This one says z varies directly with x and inversely with the product of w and y. You try that. See if you can set that one up. Z varies directly with x and inversely with the product of w and y. How'd you write it? What comes after z? Before that. Before that. Equals. Varies is equals, right? Then what? K times x, directly with x, so k times x, and then over w times y, right? The product of w and y. Okay. Okay. Last few here. So this one says z varies jointly with x and y. So you should be able to write up a general equation for me. I'm going to write it over here because it's not our actual equation yet because they're giving us numbers. So we're going to plug numbers in. So z varies jointly with x and y would be what if we kept k in it? Kxy. Okay. What you need to do is you need to write an equation where we drop a number in just for k. But to do that, you have to drop in the z, the x, and the y so we can solve for k. Okay? So that's what we're going to do. We're going to take z, 28, equals k we don't know, x is 7, y is 2. Okay, so 7 times 2, that's 14, right? So we're just going to divide by 14 and divide by 14. So this is 1, and we get k equals 28 divided by 14 is 2. So our equation takes that 2, drops it in here. So z equals 2 times xy. Did you follow? You good there? Okay. So then it says find z if x is 6 and y is 4. What are you going to do? Plug them in, right? Now we have our equation. Plug them in here. So z equals 2 times 6 times 4. So z is what? 48. Okay, you try 9. 9's a little bit fancier, but I believe in you. You can do it. Z varies directly with x and inversely with the square of y. Directly with x, inversely with the square of y. I got a double A battery.
The office has one that can make rabbits for you.
I'll have you go grab a little bit. Let's finish this. But thank you. All right, how did you set it up? Don't give me the number yet. Just tell me how you set it up with letters. So z
equals kx over the square root of y.
Ooh, the square of y. What is the square of y?
Y squared.
Y squared, right? So close. You're in the right ballpark, but y squared. Okay, so we're here. Then what did you do? Plug in your numbers. So you're going to say z, so 50, equals k times 35 divided by 7 squared, okay? At this point, I would probably just take it one piece at a time. 50 equals 35 k divided by 49. I would probably multiply by 49 first, and then you can divide by 35. Or right off the bat, you could multiply by the reciprocal. If you like that better, that's great too. I don't have a calculator. What did that come out to? 70? Yes. Is that what you got? So z equals 70 times x divided by y squared. So when they say write the equation, you need to plug a k in, but everything else should be variables, okay? That's your equation. So you're always going to drop the k back into that first purple one there. And then it will say find some variable when your other variables equal these numbers. So now you can drop in z equals 70 times 5 divided by 10 squared, okay? So simplify that, 350 divided by 100. So z is 3.5. Questions on that? All right.